learners, in this presentation we would be dealing with how to compute chi-square in SPSS. Chi-square test is one of the simplest and most widely used non-parametric tests in statistical analysis. It makes no assumption about the population being sampled. Using chi-square test, we can know whether there is a discrepancy between theory and observation, and also whether the discrepancy can be attributed to chance or whether it results from inadequacy of the theory to fit the observed facts. The chi-square is used by the researchers in two ways. First is a test of independence and the other is goodness of fit. Chi-square as goodness of fit, it assesses whether the fit between the observed and expected distribution is good, and therefore it is applied generally for single categorical variable. Chi-square can also be used to evaluate the relationship between two or more variables. This helps in stating any significant association is there between these variables. So the chi-square is used to examine the association between two or more variables measured on categorical scale. For this, a function is there in SPSS, that is crosstabs. So crosstabs can be used with the continuous data if such data are divided into separate categories, and hence it is used for as a test of independence. Now let us go through the assumptions of chi-square test because only then it will give correct results. First is the sampled observation must be independent of each other. Second, the sample data must be drawn at random from the target population. Third, the data should be expressed in original units for convenience of comparison and not in percentage or ratio form. Fourth one is the sample should not contain at least, and it should not contain less than 50 observations. That is, it should have 50 or more observations to compute this test. The sample data should have more than 50. There should not be less than 5 observations in any one cell, and hence if you will have less than 5 observations, the value of chi-square shall be overestimated and will result into too many rejections of null hypothesis. So let us go through how to compute this chi-square in SPSS. First, go to the file. Now this funds.sav file contains data of 35 respondents in which variables are age, funds, stream, gender, height and weight. Now age is the age of respondents. Funds tell or depicts or explain the preference of funds in terms of the cost. Stream is educational background, whether there is from these respondents are from science, arts or commerce stream. Gender, height and weight are also given. Now as a researcher, if you want to set out to test whether there is a significance in people cost preference for funds, if there is no preference, then we would expect each category of cost equality. On performing experiment, the researcher find that there are differences in the preference of the funds frequencies. So using analyze descriptive and then go to frequencies, transfer funds and then display frequency table. So now researcher find out that 11 people they preferred least cost fund, 13 preferred lowest cost fund, 10 people selected moderately cost fund and only one respondent selected highest cost fund. So now the question arises, do these observed frequencies differ significantly from the expected frequencies? The observed count, how many people preferred each fund depending upon the cost, would here be computed. The expected counts confirm how many people we would expect to choose each cost of fund if null hypothesis was true. So now let us compute chi-square. Go to analyze, then to non-parametric test. The option would be there, legacy dialogs. Go to legacy dialogs and then click chi-square. Now click to chi-square. Transfer the variable on which you want to attempt chi-square test in the test variable list using arrow button. So this how you can transfer. Keeping other thing as default, go to option. Click here in checkbox to descriptive, that is you also want to know summary statistics of this variable, and go to continue. In sub dialog box, then click OK in dialog box. This type of view will come in output viewer, in which under the the non-parametric test, first table will explain about descriptive statistics, in which mean, standard deviation, minimum and maximum along with the number of respondents would be displayed. In second column, that is in chi-square test, frequencies would be displayed, the one which we just now saw, along with, that is, observed number and expected n and residual. So visual inspection of the differences between observed and expected values reveals wide discrepancies. The residuals are observed values minus the corresponding expected values. So we can see that chi-square here is 9.686 at 3 degrees of freedom, and p-value is less than 0.005. So we can therefore conclude that there is a significant difference between the observed and expected counts, and we can therefore reject the null hypothesis, the four cost of funds are not equally preferred. There is one more option, that you can compute chi-squared if you want to give cases, weight to the cases. So go to data, click to weigh cases, transfer funds variable in weight cases by, and then click to OK. Now here you will find a message weight by fund, and in funds.sav in data editor you will see a message will come weight on in status bar. This means weight cases is command has been executed. Now go to analyze, non-parametric test, go to legacy dialogs, and then chi-square. Transfer that variable in text variable list, go to option, click descriptives, and then continue. Now, keeping other thing as default, click OK. Now this type of view will come in output view, in which descriptive statistics are there, frequency, observed and expected. Now you can see this expected number is different from what we have when weight cases were not there. It was 8.8 here, and when weight cases were on, it was 17.8. Chi-square is also 25.507, which is different from earlier, which was 9.686. However, at 3 degrees of freedom, however, p-value is less than 0.05, which reveals the same interpretation. That is, we conclude that there is a significant differences between the observed and expected count. So the data can be entered as frequency count if the weight cases command is used. You can see that the result in this exercise is a little bit different. However, interpretation is the same. There is a significant difference in expected and observed frequencies. As such, we reject null hypothesis, except that there is difference in preference of funds on the basis of cost. Now there is one more option in SPSS, that is using the same non-parametric test, legacy dialogs, chi-square. Now if you want to now mention the percentages of preference, you have some hypothesized value. For example, you have 4 options from least cost fund to high cost fund, 1, 2, 3, 4. So 1 to 4 range has been depicted, and now you want to add values. Let's suppose you want to go for that least cost fund, that is option 1. Only 10% people prefer it. So go write 0.10, 10%, and then add. And now you assume that 20% people select second option, and 30% prefer moderately cost fund, and 40% people prefer high cost fund. So options, click descriptive in checkbox, continue, then OK. Now this type of result will come, in which first will depict descriptive statistics, second with chi-square test, and third is test statistics. So chi-square test will reveal about the frequencies and the expected n along with the residual values, and the test statistics is reveal chi-square, and you can see that the expected n and residual values are changed from the previous one. Now chi-square is 36.465 at 3 degrees of freedom, and it is less than, p-value is less than 0.05. So you can see here that the interpretation is almost the same. However, that the percentages, you find that there is a significant difference in the preference, and you cannot bound your data with 10, 20, 30, 40% of the respondents. Now there is one very important option when you want to find out chi-square, use chi-square as a test of independence. Now this can be computed using analyze, descriptive statistics, then go to crosstabs. Now once you will go to crosstab, a dialog box would appear. Now you select fund variable in rows and stream. That is, now you want to find the interrelationship or the association, the significance of associationship between these two variables. That is, you want to know whether the preferences, cost preferences was dependent upon the stream of the respondents. So select stream in column and funds in rows, click to statistics and then chi-square and then continue. Keeping other thing as default, click OK. Now this type of view will come in output viewer, in which first would be case processing summary, second is the cross tabulation of fund with the stream, that is 2 respondent of science stream choose least cost fund, 9 respondents from art stream choose least cost fund, and 10 from science stream choose lowest cost fund, and so on and so forth. You keep on analyzing. Now chi-square test comes as 34.565 at 6 degrees of freedom, and this is less than less than 0.005. So you can find that there is a significant difference in the stream and the cost of funds or the funds invested by the respondents. So this how you can find out the significance difference in the relatedness of the variables. So these options are available in SPSS for computing chi-square, and try it out with the hypothetical data or the funds or academic index file posted in LMS. Happy learning.